Today we're going to look at the relationship between division and fractions, and that usually has to do with looking at the remainder of a division problem and interpreting it as a fractional part. So I'm going to just start with a quick review of division, and I'm going to start with a problem that's pretty easy. I'm going to say 32 divided by 8. Okay, so the parts of a problem, obviously if we do this we know that our answer is 4. Most students can say that the answer to a division problem is a quotient. Then we have our divisor, the number we are dividing by, and the number that we are dividing is called the dividend. Okay. Now in this case there's no remainder. I could easily represent this by drawing 32 pieces. This is also called an array, and putting them into groups of 8. So here would be a group of 8, here would be a group of 8, a group of 8, and a group of 8. So in this case 32 divided by 8 is 4. Now the relationship, and most students by the time they get to 5th grade understand that relationship. The hard part about transitioning into fractions is thinking about what those fractional parts really represent. So I'm going to do a slightly different problem that will have a remainder. I'm going to say 32 divided by 6. Most students will go ahead and do this problem either using partial quotients or the traditional method. I'm going to use partial quotients. 4 times 6 is 24. I'm going to subtract. Get 8. How many times will 6 go into 8? The answer is once. I'm going to subtract 6, and I will get a remainder of 2. So most students would write their answer as 5, remainder 2. When we go to deal with fractions, and again I'm going to use an array because it really demonstrates to the students what that remainder represents. I'm going to use the same array. And this time, instead of by groups of 8, my divisor was 8 in the first problem, my divisor is 6 in this problem. So I'm going to make groups of 6. Now if you take a look at this array, you will see that I have 5 full groups of 6. And I have 2 dots that don't fit into an array, which is in traditional division, that would be listed as a remainder. When you are dealing with fractions, you simply look at that remainder and you say, what would that 2 be of? Well, that's 2 out of what our divisor would be, which is 6. So there's 2 left out of 6 more. So in using this to show the relationship between that and a fraction, instead of saying remainder 2, I would say it is 2, 6, because it's 2 out of there would have been, to make this equivalent, 6 more of these, but I only had 2. So when you are when you're going from division to fractions, It's just simply a different way to report the remainder.